Hello, we will discuss the MAC protocols, medium access control protocols, which will come into the unit 3 of data link layer. Basically, the data link layer is divided into two parts. One is data link control and another is multiple access resolution, which is another named as MAC, medium access control. The data link basically consists of many parts such as error control, flow control, while the multiple access resolution shows the contention between the many stations, as there are many stations who want to access the channel. If some stations they want to contend between each other, then they will follow the multiple access protocol. Now we have shown the taxonomy of the multiple access protocols. Multiple access protocols are being divided into three parts. One is random access protocols, another is controlled access protocols, and the third one is channelization. The random access protocols are Aloha, CSMA, which is carrier sense multiple access, CSMA-CD, which is carrier sense multiple access with collision detection, CSMA-CA, which is carrier sense multiple access with collision avoidance. Controlled access protocols are resolution, pooling, and token passing. While in channelization, we have three technologies which are being used mostly in the case of voice communication are FMD, FDMA, TDMA, and CDMA. The random access protocols or contention matters. Contention means the fight between the two stations who wants to access the channel. So, in random access or contention methods, no station is superior to each other and none is assigned to control over another. No station permits or does not permit another station to send. At each instance, a station that has data to send using a procedure that defined by the protocol to make a decision whether or not to send. Features of random access protocols are there is no scheduled time for a station to transmit. Transmission is random. That's why these are called random access protocols. And secondly, no rule specifies which station should go next to transmit. If stations fight with each other, compete among each other to access the channel to send the transmit the data. That is why these are also called contention methods. Now, problems with random access. Problems are because there are no methods that one station can control another station. So, more than two stations can transmit the data or packet or frame at the same time, and that will cause the conflict, the collision between the two frames. And if there is even a single bit collision between the frames, the whole frame will be destroyed or modified. So to avoid all of these conflicts, to resolve these problems, we have some questions in our mind. When can the station access the medium? What can the station do if the medium is busy? How can the station determine the success or failure of the transmission? And what can the station do if there is an access conflict? This is the first protocol which we use for MAC, Aloha. It is the earliest method which was developed in the University of Hawaii in 1970. It was designed for wireless LAN, but for wireless LAN it cannot be used. It is used for basically LAN in the earliest versions. It is divided into two parts, pure Aloha and slotted Aloha. Pure Aloha has a methodology that whenever any station has data to send, it will send this data. It will not wait for another signal from station 2, 3, 4 and so on, and it will not sense the medium that it is transmitting or not, somebody is sending or not. It will send its data whenever it is ready in the time. So in this particular picture we can see that frames 1.2, 2.1, 3.1 and 4.1 are being collided because station 1, station 2, station 3 and station 4 are being sending the data simultaneously. This is the biggest problem which is we have in pure Aloha.